So let's start. I called this Review of Trigonometry. It says, find the length of the missing side. You learned how to do this actually in Math 8. How can you find the missing side? Now, first of all, what shape are we dealing with? Be obvious. Triangle. In fact, tri means three. Angle means corners or angles. Trigonometry, which also begins with tri, literally means three-angle measurement. It's the study of triangles. Okay? This triangle is a specific type of a triangle. Does anybody know what we call this kind of a triangle? And it has an awful lot to do with that thing right there. It's called a right triangle. There's right-angle trig, and then there's non-right-angle trig. Right-angle trig uses good old SOHCAHTOA, and if you've forgotten that, we'll be talking about that again. Non-right-angle trig, you need to use the sine law and the cosine law. We'll talk a little bit about those too. But this year, primarily, we'll be dealing with right-angle trig. So it says, find the length of the missing side. If you have two sides of a triangle, how can you find the third one? You learned this in Math 8. It's a famous theorem. Pythagoras. Okay, so I'm going to write down here Pyth. What is Pythagoras' theorem? A squared plus b squared equals c squared. Can each of the letters go anywhere? No, there's one major thing I have to be careful of. What side always has to go in what location? Okay, just make a little note. This always has to be the long diagonal side, but what did the long diagonal side have a name of? What do we call it? The hypotenuse. A good abbreviation for hypotenuse is that has to be the hypotenuse. Everything else doesn't matter, but you've got to put the hypotenuse there. As an equation then, if you wrote Pythagoras based on this triangle, what would you say? What squared plus what squared equals what squared? Really? No, not plus 73 squared. Where does the 73, is that the hypotenuse, Mark? Where must it be? It must be by itself. It must be there. It's going to be x squared plus 55 squared equals 73 squared. So I wrote down here, in order to use this, or in order to solve this, we use Pythagoras. Let's put a little pyth there next to what we use. X squared plus 55 squared equals 73 squared. There's going to be, Taylor, two kinds of questions. You're either going to want a side, and it's going to say, here's the hypotenuse, and here's the other side. Or it's going to give you two sides, and the x is going to be here, in which case in my equation, Mark, the x will be here. But we can't assume the x is always going to be by itself. In fact, I did this one on purpose, because kids always want to put the x where the c is. No. What goes where the c is? The hypotenuse, which in this case is a number. Mark, my friend, how to get the x by itself? Minus 55 squared, and then? X squared equals 73 squared minus 55 squared. Square root. Good. Try it on your calculator, please. I think this one works out evenly. Yeah. 48, yeah? They won't often work out evenly. I had to look long and hard to try and find one that did work out evenly. Example 2, find the missing side. Now, Zach, my friend, you've been doing Pythagoras since grade 8, yes? I'm going to give you permission in your homework to do this question showing no work whatsoever. In other words, can you first of all tell me the equation, please? No, specific to example 2. I know it's a squared plus b squared. Specific to this one. Can you tell me the equation with the x by itself, please? Nope. Okay. Then right now, you don't have my permission to not show any work. So you need to go like, some kids can, and if you can, great. So you said this, I totally agree. Can you see it's 19.3 squared minus 7.6 squared equals x squared? Good. What's x? I'll live with it if you write down one line. You know what? I'm going to rescind my showing no work. I'm going to say, Olivia, if you write down one line and go straight to the answer, I'm good with that. Would I go this fast on a quiz or a test? No, I'd probably show a bit more work, but do I want you to get good in your homework? Yeah. So 19.3 squared minus 7.6 squared equals square root. Do you get 17.74? How many sig figs? Well, technically 2, but I'll go to 4 decimal places. Sorry, to 4 sig figs, to 2 decimal places. 17.74 centimeters. Pythagoras. Kylie, we can also give you compound diagrams, like example 3. Example 3 says find x and y. How many triangles do you see in this question, actually? 3. Don't write this down. 1, 2, 3. Yes? Only 2 of those have right angles. This long, skinny one here, no right angles. I can't use Pythagoras. Okay? This is what I call a hopscotch question. What I mean by a hopscotch question is to find some of the answers, you're going to have to find other stuff in the diagram and kind of hopscotch your way along the rest of the diagram. Jake, what does it want me to find first? What does it want me to find first?
Oh,
X. X is part of, can you see it? This triangle. You know what? I'll take 1 second and I'll quickly resketch this. 15x 17. Is that a right triangle? What squared plus what squared equals what squared? X squared plus equals, to get the x by itself, first of all, to get the x squared by itself, what I do, what's sitting right here, Jake, my friend. So how will I move it? Minus it, and then hit equals, and then square root. Good, do that. So this one will also work out evenly, I think. You get 8? Yeah? Okay. What's the second thing they want? Oh, you know what? Since that's one of the things they wanted us to find, Kylie, let's cleverly put a box around it. Jake, what's the second thing they wanted me to find? Find y. You know what? That's part of that triangle where that's y. How far from here to here? Yep. And then here's the clever part. How far from here to here? Y. From here to here is what? And what did we just find? X, but what did we just say x was? So, how far from along the bottom? 20. Okay. What's our equation now? What squared plus what squared equals what squared? And I hope this is review and almost boring because you want to reach the point where Pythagoras is yawning in your sleep. Chris? No, I need something squared plus something squared equals something squared. No minus yet. Okay. What squared plus what squared equals what squared? Specific to this triangle then. What squared plus what squared equals what squared? Yep. Anyone? Why is the y already by itself? Because what's by itself is always going to be the hypotenuse, and in this case, it's a variable. So here, to get the y by itself, it's mostly by itself. I got a y squared by itself. What am I going to do at the very, very end to get rid of a y squared? So go 15 squared plus 20 squared equals square root. Wow. Can't believe that worked out evenly. I must have worked long and hard on that to get that to work out nicely. 25, yes? And the rule of thumb in a right triangle, Dom, is give me two sides, I can find the third. What if you only give me one side? Then I need an angle as well. First, we need to talk about labeling triangles. If you give me an angle in a triangle, it's traditional for us to use the variable theta, which is a zero wearing a belt. Why do we use theta? Well, it's shorthand in math. In math, if I use an x and a y, I figure you're talking about a graph. If I use a, b, and c, I figure you're talking about Pythagoras. If someone happens to use a variable theta, I say, oh, you're talking about an angle. It's just shorthand. You can call it x, you can call it something, but I'm going to probably use theta most of the time. So here is our angle theta. In fact, let's put a little arc like this. Ta-da! Every triangle has how many sides? 3. And in a right triangle, we can label these 3 sides. Which one of these is the hypotenuse? What's the hypotenuse always? Let's put a little h right there. Then we have opposite and adjacent. Which side is opposite to theta, the top side or the left side? Don't write this next bit down. What if instead I was talking about this angle here? The hypotenuse is still, don't write this down, the hypotenuse, which side is opposite to this top angle? So you have to be careful, know which angle we're talking about, because that's going to affect how we label the sides. We also have 3 primary trig ratios. What are they called? Okay. Sine, not sin. Sin is when you swear in my class. Sin is when you're late for my class. Those are both sin. Sine is the trig function. Abbreviated SIN. Cosine, abbreviated cos. And what's the third one? Tangent, abbreviated tan. Your calculator has all 3 of these on it. If it doesn't, you got a POS calculator. Evaluate the following to 4 decimal places on your calculator. Now we have a bit of a problem. We measure angles 3 different ways. We measure angles in degrees. How many degrees are in a circle? 360. We also, in engineering, measure angles in radians. Anybody know how many radians are in a circle? And the answer is 2 pi. Say what? Trust me, it's handier in many ways. We also measure angles in gradients. Anybody know how many gradients are in a circle? 400. 400. Don't write this down. Nerd moment. If there's 400 gradients in a circle, how many gradients would there be in a quarter circle? 100. And the reason we use gradients in engineering in road construction, because if it's out of 100, that also automatically means it's a percent. How many have been driving on the freeway somewhere and you see a sign that says truckers gear down and then there's a percentage grade? They've measured that hill in gradients, and the gradient measurement is the percentage grade, and you can even hear the word grade, gradient in there. I have a mathematics degree. I did 4 years of mathematics. Alex never used gradients once. I looked it up because I was a nerd and wanted to find out where it was, because I noticed I had this G on my calculator that showed, what the heck is that? So anyways, nerd moment over. You need to make sure your calculator is in degrees. The way to find out is find the sine of 32. Sorry, sine of 42. And you should get 0.669130. If you don't, your calculator is some other mode, and you need to figure out how to get your calculator in degrees. Now is your chance to ask. But all of you need to try this, please. 0.6691. Anybody not getting 0.6691? So mark on your calculator, because you have a graphing one, By default, it's going to go to radians because actually in math, radians is used far more commonly than degrees. So you have to check this fairly often. Press the mode button right here. And then go down arrow and hit enter to highlight degree. Okay. Okay. Chris, we are so proud. We're so proud of you, Chris. We are so. Hang on. We are. Hang on. You know what? Here, hang on. Here we go. There is a gap, right? There is a gap between. We are so proud of you. So proud of you. Okay. See if you can get that then. Go sine 42. Now, you also need to figure out how your calculator works. My definition of a crappy calculator is one where you have to go 42 sine equals. I don't write it that way. I don't say it that way. Why should I type it that way? Answer, because you're cheap. Because you're cheap. Hopefully you have a calculator that actually lets you go sine 42 equals in the same order that you write, I hope. Anyways, everybody get the 0.6691? Okay. Find the next three on your own. I'll freeze the screen. Again, go to 4 decimal places. Find the cos of 76. Find the tangent of 45. That one I actually know. And one of these will end up being a bit weird. Which one gives you an error? Okay, you can't find the tangent of 90. We'll talk about why some other time. But I got 0.2419 for the cosine of 76 degrees. Tangent of 45, I happen to know is 1. It's a nice round number. And a 45-degree angle is a nice angle. I've got a few memorized. Not very many, but a few. Tangent of 90 is undefined. You know what? What's the tangent of 89 degrees? Try that. Let's try tangent of 89.99. Let's see if we can sneak up on 90 and take a guess. Let's try tangent of 89 point. Let's do 4 nines after the decimal. 9999. As we get closer to 90 degrees, what happens to your answer? So in calculus, those that take calculus next year, we would say the tangent of 90 degrees has a limit that approaches infinity. The closer you get to 90, the closer you get to infinity. Hey, really want, tan of 89.999999999. There, I'm in scientific notation now. Okay. So, as far as I'm concerned, I can give you an angle and say find the sine or the cosine of the tangent. I can also go backwards. Suppose I told you that the tangent of some mystery angle was 3.732. How can I find the mystery angle? Who remembers how to do that? Okay, this is where it's going to be shift or second function or inverse, or it's almost always the top left corner of your calculator. I don't know what yours is called. Second function is what mine is called. Shift is what some of yours is called. Inv is what some of yours is called. Those are the big 3. And what you can do then is you can go inverse or second function tangent. Type in the value that they gave you. And it'll say, oh, that second function, that shift tells your calculator, we're going backwards. This time I'm going to give you the decimal value, and I want the angle that it came from. You get 74.999. Oh, really, what angle is this? Yeah, it's 75 degrees. See if you can get that. Okay, see if you can use tangent, the shift key, and 3.732 so that your calculator spits out 75 degrees. Anybody else, anybody not able to do that? You need to know how your calculator works. It does. We just need to figure out how it works. Be right there. So now that you know that, try example 5 here. Solve the following 3 equations to the nearest degree. find the angle that each of those went with. So sine of A equals 0.5. What's A? Cos of theta equals 0.5. What's theta? Tangent of theta equals 0.4877. What's theta? Use your shift button. I'll freeze the screen. Let's see if we get the same thing. You know what? The first one I know. Second one I know. Third one I don't know. Let's see if you get what I got. Is it 30, 60, 26? I hope. Okay. Jake, figure it out? Yeah. Grant, figure it out? Let me come help, because when I see two kids staring at a calculator. Okay. Everybody knows now how to find the sine, or if I give you the sine or the cosine or tangent, how to find the angle. Big deal, huge deal. We can combine that with triangles. This brings us to our definitions of sine and cosine and tangent. Recall, we said that sine was opposite over hypotenuse. Tangent was adjacent over hypotenuse, and cosine was adjacent over hypotenuse. Tangent was opposite over adjacent. And we had this acronym, Jake, SOHCAHTOA, where this told you that sine was opposite over hypotenuse. Cosine was adjacent over hypotenuse. Tangent was opposite over adjacent. You can see it in the acronym. In fact, I teach my students when you're doing this unit, when you're doing any trig, this is one of the things you write at the top of the page anytime you turn the page. Cuts down on your thinking. We combine that with our calculators, and now we can solve triangles. Example 6a, it says, determine the length of the indicated side to the nearest point 1. First thing I always do is identify what angle they gave me, and I color it like that. Do that. This is the question's no longer blank, Brad. You feel better. You've colored something. Routine. Now that I know that angle, I'm going to label the sides. The x is that opposite, adjacent, or hypotenuse based on that angle that I've colored. Put a little O there. The 15 is that hypotenuse or adjacent. Put an H there. I'm going to give you some advice. Do not label the third side. I know there are some teachers that tell you to label all three sides. I think that's silly. First of all, what two letters are on my triangle right now? H and O. Go look at the word SOHCAHTOA, which is the only trig function that has the H and the O in it. I think it's fairly obvious, sine. If, Noah, you did that, look up, if you label that with an A, because I see some teachers just have the kids always label all three sides. Haven't you made it more difficult? Because now you've got three letters to pick from, and you got to pick, you know what? That's wasted effort that made it more difficult. Leave it blank. Blank sides, I leave blank, unless I need to use them later, but then I label them later. Which trig function? Sine. What always goes next to the trig function? The angle. What's the angle here? Equals. And what was sine defined as? What over what? Now, more specific for this triangle. What's opposite? What's hypotenuse? What am I trying to get by itself? The x. What else is on the same side as the x? We're dividing by 15. How would I move it over? X is going to be 15 times the sine of 57. You get 12.58? It said to the nearest 0.1, so I guess 12.6 centimeters. You don't realize how profound this is. This is hugely, hugely useful and profound. B. First thing I always do is I color the angle that they gave me. There. Then I label my sides. The x, opposite, adjacent, or hypotenuse? The 11.1, opposite or hypotenuse? Opposite. OA. Tan, what you do at the beach. What always goes next to the trig function? Equals what over what? Well, it's opposite over adjacent, specifically for this one. What over what? This time the x is on the bottom. Where was the x on the previous one? Those are the only options. The x is going to be on the bottom or on the top. How do I solve this one? Well, I want to move the x to the other side because it's on the bottom of a fraction. Right now, the x is being divided. That's the same as having it times right there. That would give me, don't write this down. Don't write that down. How would I get the x by itself now? What's the tan 28 doing? That's how I move it over. Okay. So Brad, x is going to be 11.1 divided by tan 28. You know what? There's two questions. X is on top. It's the trig function times the number. It's the number times the trig function. X is on the bottom. It's the side, you know, divided by the trig function. You know what? If you want to, you can kind of memorize that, or you can derive it if you need to. 11.1 divided by tan 28. And I get 2.1, I guess? Yeah? Oh, I typed that in wrong. 11.1 divided by tan 28. I get 20.9? Centimeters. You can also use this not only to find missing sides, but to find missing angles. So this next one, example 7, says, determine the measure of the indicated angle to the nearest degree. Okay. What angle do they want me to find in part A? What's the only variable sitting on the triangle? X. You know what I'm going to do first? Color it in. Yay, I wrote something down. I feel better. That 15, opposite, adjacent, or hypotenuse. That 7, opposite or adjacent. Which trig function has in it? Cosine. What always goes next to the trig function? The angle. What's the angle this time? I'll give you a hint. It's a variable. Okay. Equals what over what? Here's my setup. This time, Dom, I'm being asked to find an angle as opposed to a side. I would argue it's really similar to example 5, where you're being asked to find an angle, except in example 5, I had given you a decimal instead of a fraction. But how did we find an angle? Second function, or shift, or inverse. So you know what? I got a good calculator. I'm going to go like this. First of all, shift which trig function? So I'm going to go second function, cos, open bracket. Now, my calculator automatically opens a bracket. If yours doesn't, open a bracket. And we can, instead of decimalizing it, we can just say, you know what? It's 7 divided by 15. Close bracket. We can get the calculator to do the arithmetic for us. How big is angle X? 62.2 degrees. Okay. By the way, the abbreviation for angle is that, because it looks like an angle. So angle X equals, what did I say? 62.2 degrees. Next one. What angle are they asking me to find here? Because I asked you to. What angle are they asking me to find here? Y. Because I asked you to. Really? You walked right into that one. Angle Y, you say? Dom. Redeem yourself, Dom. That 8.1, opposite, adjacent, or hypotenuse. How about that 14.5? Yeah, for a second I was going to say adjacent, and I went, no, it is the hypotenuse. Which trig function? Sin is when you swear in my class. Sin is when you're late for my class. What do we call it really? Sine. What always goes next to the trig function? The angle. What's the angle this time? Because I asked you to. Yeah. Goes what over what? Okay, there's my setup. So how big is angle Y? And this is all calculator work. Shift, sine, bracket, 8.1 divided by 14.5, close bracket. And again, what I'm telling my calculator to do here is whatever decimal 8.1 over 14.5 is, give me the inverse or the shift or the second function sine of that. Give me the angle that came from. And you can do it all in one step, Chris. What do you get? 33.96, I guess 34 degrees. Can I find a side? Check. Can I find an angle? Check. What if they give me a compound diagram? Okay. Oh, I didn't. Never mind. Didn't give you an example of one. What's your homework? So number 1, all. 2, all. 3, all. Mr. Dueck, how will I type that into my calculator? Probably square root of 2, close bracket, divided by 2 equals square root of 3. You can do it. Okay. The ones you're going to find tricky are a couple of word problems here. Okay. You know what? I think there's one I'm going to nuke. Oh, no, never mind. No, I'm good with that. Your hint here for number 7 is, what does DOLP stand for? Draw a little picture. Same with number 8. I haven't done a word problem with you. See if you can figure it out. I'm going to let you wrestle with it. The answers are attached. Oh, there is a part 2. Tougher questions. Okay. Yeah, 1 is good. 2 is good. These are nasties. These are compound diagrams. We're going to have to hopscotch. See if we can figure it out. Yeah, everything. Your real homework, of course, is to study for the test next class. So this is due not next class, but the class after the test.